Rakaya Fletcher. Welcome to Tech Tuesday at 2 in the Edmund Lowe Creative Studios. The Creative Studios are here for students to learn about and utilize new software and technology that can allow them to both express their creativity and help in their success here at OSU and in the future. Tech Tuesday at 2 will meet here in the Edmund Lowe Creative Studios on the first Tuesday of every school month for an interactive showcase of emerging and innovative technology. Last month, we learned about creating GIFs. If you missed out or simply want to just watch again, all of these programs are rebroadcasted on O State TV and can also be found by searching the library's website for Tech Tuesday. Today, Awilda Rodriguez for the OSU of Architecture will be giving us an overview of virtual reality. If you are here in our audience, you can ask questions at any time during the presentation, and I will be glad to come by and help. If you are watching on today's live stream, you can submit questions via Twitter or Facebook using the hashtag LibTech2s. At the end of the program, we will be drawing for prizes for OSU students who are in the Creative Studios with us today. So please be sure to fill out a prize entry form. Awilda, take it away.
I wanted to like sit here and just show you stuff, or can you can hear me now? Or I think that might be too loud. Or kind of walk the room and come back, so I decided that I'm gonna walk the room and come back. So my name is Awilda Rodriguez. I've been teaching here for 9 years, and I teach at the architecture school. I teach design studio. And we are all need to teach like a seminar course. So my seminar course is in computer applications. So I mainly teach our students how to get their designs from their paper into 3D, if not 3D directly. So I wanted to start with this image here, because this image is kind of very meaningful to me. And I see there is a different range of ages here, so I don't want to age myself. But you know I'm old, so that's okay. But I first came in contact with this as a little girl. Did anybody else came in contact with this? Because I know there have been few versions of this. Okay, so I had a small operation. They took my tonsils out, and my aunt showed up in the hospital with this little toy for me. And that was my first interaction with this idea of being inside something, like trying to like immerse yourself into an image. And I found that it was a great toy for me. I don't know if it is what decided for me to go into computer applications. I think that might be too much. But the second thing that actually started kind of impacting me was I went to Disneyland, to Epcot Center when I was 9. And again, I don't know if you guys remember, there was the Circle 360 Degrees Theater. Anybody went there? Yeah, yes, okay. So you actually had to have a handlebar. Did anybody get dizzy there? So it was this fully immersive experience of being on London, being on different parts of the world. And that was my second experience, and it was pretty great, of like trying to kind of immerse yourself into this virtual world. So we have been kind of always trying to strive for like trying to understand the reality versus this virtual world. We have always tried since the 1960s. We have been trying to kind of make it better. So in 1994, I have to look at my notes, actually is where the virtual reality modeling language got invented. And my first interaction was in 1997, where I was actually working as an architect in Phoenix. And we were the beta testers for a software now called ArchiCAD. It's made by a Hungarian company, Grassosoft. And we were actually doing VR, even though I didn't know it. We were actually doing VR. So we will do these little kind of movies of a space. Like I will take a space like this, and we will set up a camera in the center, and we will shoot the room completely and at a different frames rates. And back then the computers were really, really slow. So we were going to like 30 frames per second. Wasn't very much. So once you move, it was like this. And then we will actually stitch together those movies. So the idea of teleporting was that you click on a wall and it would just take you to another movie. But that was kind of the beginning VR. So we have actually moved much more sophisticated from where I started. And I think for a while, kind of VR disappeared completely, like you didn't hear anything about VR. And I think it's because the computers were not there. They were not there to really harness the power of what they can do. But now we have pretty sophisticated and fast computing power. Yes. Okay, so this VR idea, it takes three main components. There is the human component, there is the hardware, and then there is the software. So the hardware wasn't there for a long time, and now we are actually having the hardware catch up. The software was available, but didn't have the hardware. And humans, we have always been here, so that's not a problem. And now we can actually see how we're going to mix this together. So in architecture, I'm going to talk mainly how are we using it in architecture. So in architecture, the way that we visualize things is that we make drawings, no? And we make drawings that are actually kind of describing a section or a partial of something bigger. So sometimes when clients are, I call it like my grandma type of client. It's like they're not educated on reading drawings. So it's really, really hard for them to actually understand spatially what's happening here. And even if I show renderings of this bathroom, it's really, really hard to kind of gauge depth. So I've been teaching computer applications for at least 16 years now. And one of the biggest problems that I see on the virtual world is the fact that it's really, really hard. You lose two things. You lose contextual information, so you don't know how big things are. You lose a sense of scale, because scale is relative. So when you are buying something on eBay and it's really small, what do? They put a pencil, they put a quarter. That's basically to give it, so you know how big is that necklace or how big is that ring. So that's the first thing that goes out in a virtual environment. You lose that perception of scale and depth. And the other thing that gets thrown out in a virtual environment, and this is something that I kind of, is kind of actually the hardest thing to teach, is that there is no gravity. So when I see students that are showing me a steel beam and it's 50 to 60 feet just hanging out there, it's only supported on one side. In the virtual world, it exists and it works. So my way to actually overcome this is that I actually have them, say we're gonna do a physical model, and now you're gonna show me that beam and we're gonna put it here. And we're going to compare the virtual environment to the physical environment, and we're going to see how it behaves. Because they're two different environments, and not until we resolve those major issues, we're still kind of striving at this kind of real or hyper-real, immersive environment. So you guys, how many are gamers here? Yeah. So the whole VR, virtual reality environment, kind of got revived. And it wasn't for the architecture industry, because we actually are not that innovative. It actually started, it revived itself with the gaming industry. So you guys playing games, trying to get into that Mario Brothers or the NFL, trying to be on that stadium, that's brought the whole technology back into the main. And then I will say also that the military have been using it too for military assignments. So like if they had to put some equipment in some dangerous part of the world, they try to simulate that, so when you are in the real situation, you know what the dangers are. So I want to talk about this. So right now, what the technology that we have right now is these headgears. And the problem that we have with this technology is that first you have a cable that is connected to, so it's not wireless. So you're very, very conscious of you walking with this cable. The second thing is that if you use glasses, like I do sometimes, it kind of changes the focus. So it's really hard to readjust. So it has kind of those problematics. So it's kind of immersive, but not there. So where are we moving with this? It's actually going back to the Disney, to the 360 degrees idea. And we are starting to abandon the idea of the headgear. And we're actually moving more back into the 1960s of a full immersive environment. So here I'm showing an example of an engineer checking the design of an interior of a plane. So the first is wireless, so you don't have to drag the cable all over. And second one, it is a much lighter gear that if you're using glasses, you can accommodate them. So there is just like these little sensors here that is sending back to the software, like where is your eye level? And it's just feeding back and forward. So this is where we're going with this. So we're going back to the fully immersive, trying to get away from this. So that's kind of the future. Okay. So there are different ways of visualization. I want to go back to, so we have mixed reality, we have virtual reality, and we have augmented reality. So right now, I'm going to mainly focus my presentation on virtual reality. So virtual reality is trying to just come up yourself into a virtual world, which augmented reality kind of got famous with the Pokemon game. So it's actually the real world, and then we adding objects to it. Okay, and then we have what we call mixed reality, which is actually bringing these two technologies and making a tertiary that is more immersive. And the last one that I mentioned is the immersive visualization cave, which is, you know, the most immersive is going to be that we just walk as normal human beings without cables, without goggles, and we are actually feeling that space. Okay, so the VR software, I want to demystify because it sounds like really, really high tech and like something that you spend a lot of time doing. But actually, most of the work starts with your 3D environment. So the better 3D environment you have, the better VR experience you will have. So I know in our high schools we teach, we're teaching for like STEM programs, we're teaching SketchUp, and I think I talked to you guys know SketchUp, or you know Revit, okay. And so SketchUp is a very, very kind of easy software where you might just draw a line and you pull it up. So it's very kind of intuitive. You don't have to know CAD, you don't have to be an architect. You are just kind of drawing and pushing and pulling. So it's almost like an artist. SketchUp tends to be very basic, so we don't use it like in upper levels in architecture. because we need to extrapolate more information. So SketchUp is something that we might use at the very beginning of a project and at very early years in architecture, and then we kind of graduate them to more upgrown softwares. But it's actually very useful if you know that your project is going to be kind of simple and not very, doesn't have complexity of curves, okay? So you can actually start with a SketchUp model, and you can bring it into Revit, because Revit and SketchUp talk to each other. That's not always true for all softwares. So, but it happens that SketchUp talks to Revit. Okay, so I want to start here. So we actually start with the 3D environment. And in the 3D environment, obviously, you are creating all these objects. So there is a new technology. It's actually not that new. It's 10 years old. But we're still talking as it's new. So it's called Building Information Modeling. Is anybody familiar with BIM technology? You are. OK, so we're kind of going away from this idea of just 3D rendering. And we're actually making objects and environments that are actually smart so that they can recognize many things. So I will give you an example. I am designing a bathroom, and there is a plumbing wall, okay? And attached to the plumbing wall, there will be a lavatory or a toilet. So in a BIM environment, that toilet or lavatory will be looking for a wall that has plumbing. It's not just looking for any wall. So it has that intelligence. So it will attach itself to a plumbing wall, and it will know that, so it will get hosted. And then during the process of design, if that wall gets deleted or changed, what will happen to that fixture? Any guesses? Well, if you delete the wall, the toilet is deleted and the fixture is deleted. If you were to move the wall or adjust it, that toilet or fixture will adjust with it. So this is where actually we're moving. We're moving to this idea of smart objects. So let's open this. And I'm being very brave today because I'm actually going to do everything live. So I could have just have a PowerPoint and then just say, well, this moves here, this moves here. But since we don't have the headsets and all of you cannot be in an immersive virtual world, I think this is going to be the best way for you to kind of understand the technology. Okay. So you start modeling your 3D on a 3D software, and there are several 3D softwares there. They don't have to be BIM ones. But the BIM ones become really useful when you are in a virtual environment, and that will be because when I'm showing a client and they're within that environment, I can say, okay, click on that table there, and since that table is a smart object, it will tell the client its materiality. It will tell the client the manufacturer. It might tell the client the price if I actually input that data. So they are not just navigating on virtual space. There is also this very specific information that is being what I would call augmented information, but it's not augmented reality. Okay, so we actually introduced virtual reality lab in our library. We have an architectural library, and we had some technical issues last semester, so it was towards the very end of the semester. So we have a studio, a creative studio there, and our students didn't really get to use it the way I wanted to, so I'm not showing you today's student work. I'm just showing you the capabilities of the software. So You will start your environment on the 3D, and you will be putting your lighting, you will put in your materials, so your texture maps, and any objects that will need to actually create your environment. The second thing you will do within the 3D environment, I'm not in virtual world yet, is that you will identify views, specific views that will transfer into the virtual world, has something that are like little markers where I can tick, and it can take me to that location immediately. So in this case, you see these 4 views here. Those are like tick marks that will be transferred into the virtual world. Any questions about this yet? Okay. Okay, so once we have put materials, we have defined our sun path. So we usually have to put a coordinate. Like if I'm working in a project in Alaska, I will have to put all the coordinates for it so it can calculate the sun. And that information will be actually transferred into the virtual world. Then we actually will package all this. So there is kind of like a little translation. So from the 3D environment, it will get like packed. And then we will bring it into a VRML software. So I usually use Enscape, but in this setting today, I couldn't make it work. So I'm going to be showing you this is Revit Live, and I had already gone through the process of packaging the 3D and bringing it into the VR environment because it takes a while. But all this job is actually done on the cloud. So once I package it, Revit sends it to the cloud. It resolves all the math and the data up there, and it sends it down back to my computer into the VR environment. So in this environment, the way that I see that my clients benefit the most is that they can understand proximities of things. So how is this important? So when you're in a hospital and you're designing an emergency room, which I have, or operating rooms, distances there are really, really crucial. So for me to take a nurse or a doctor and run them through that emergency room or that operation room and know what the distance is from the instrument to the operating table to where they keep more, the hazardous, so that they understand, they can actually walk the space and feel comfortable with his, okay, this is only 4 steps away, I have my patient here, I can handle that, or they can tell me, say, okay, that's too far away, it needs to get closer. So before VR, that kind of data will be given to me once the building was already done. So at that point, we have spent a bunch of money, and changes are a little bit more painful, no? So VR is really, really making this transition for clients to understand a spatial quality much better. The other thing that this has a lot of use is actually on materials. So also clients cannot, the way that we attach materials is that we show them there, but they really don't understand how the whole composition comes together. So, if I have a very dark room, maybe in the morning you have the sun and it will look like there is enough light on the space, but then as the night falls and the artificial lighting starts taking place, it's really hard for a client to understand, and then the algorithms are still, they're kind of there, but it's still kind of a jump for a client. Okay, so I said I was going to do this live, so I'm gonna sit now. Okay, so I have packaged this and opened it. If you look on the right upper, you see the views. These are those 4 views that I already told you that I have marked in my 3D environment. So if I click on there, they will actually have those tick marks, and I will just immediately go. So for a client, to say, okay, where is the lobby? That's very easy to navigate. So we're gonna try to attempt to navigate here without a mouse, but that's okay. Okay, so I don't know if you guys can see that X. That's my next location. So that will be the equivalent when you're having the headset and the controls, the teleport. Okay, so I'm teleporting here with my mouse. Okay. So it's gonna to be a little bit slow. Okay. But you can really understand here, how you build. This is a kitchen. So, if this was my cooking kitchen, I can start kind of as a client understanding what is the cooking plane versus the cleaning plane, and if this will be working for me. So we're gonna attempt to go upstairs. Okay. Obviously, this will be more easier if we have the. So we are in the second floor now. Okay, so you can see how easy it is to kind of navigate. Obviously, if I had the teleport, it would be so much faster, sorry. I wanted to do it live. This one doesn't have a lot of materials, but what I'm trying to say is that the more time you spend on the 3D environment, the better this is going to be of an experience. So virtual reality is like once you get it into the VRML language, then it's just a question of navigating through it. The real work is being done in a 3D environment and understanding the 3D environment. So I'm just going to show you how the sun works here. So has a designer it is kind of important. Let's see, I need to move away from the window because I want to see the window. Okay, I want to position myself here so you can, okay. Okay, so one thing that we actually have to do in architecture is to try to figure out how much energy the building is going to be using, and also the amount of daylight that a room will get. So in VR, we can actually show a client already kind of formulated so that I can see how the sun is working. And if I have to, it's not moving. Okay. So like in this case, let's say that this was a western exposure and this room was getting way too much sun. So it will allow me to go back and change the design and cut on that sun. So the client will actually see the path of the sun throughout the day and see how the room actually works. Okay. I think that's it. I'm going to be opening for questions.
How long have you been incorporating VR into your architecture education?
We just started last semester. Yes. So, and I think it will have a great impact for the two reasons that I mentioned before. Students don't understand the scale of things, and having something that is very familiar, you know, one way that I actually teach them is like put something that make a little model of your house or your car, put it next to your design, because you know what size it is. So I think it's going to help bridge that. I think that the biggest problem we're still having is the gravity issue. So.
What kind of learning curve do you see with your students? So they've never developed a virtual reality environment before. How long does it take the average person to get proficient enough with the software that they can really start working with it?
I think for the purpose of what we're doing in School of Architecture, I think it will be a very easy transition, because once they actually spend the time on the 3D model, putting all the information, it's a question of using the VR to understand the information. And there is a back and forward interactive process. But if they want to kind of program the VR, that's going to be a higher level like learning curve. But I don't think at this point that's my goal right now. Yeah, it's outside the goal of teaching them how to actually hack the virtual environment. Somebody had a question back there?
Is there any thought in the future for when students build these virtual reality constructs to actually use 3D printing to take virtual into the physical so they can see what gravity and actually will affect?
So we're trying to kind of tie all this media, so they can do a 3D printed piece. We can scan it. We can bring it back into the virtual world, massage it, and then reprint it again. So we're trying to kind of close the circle of using, it's kind of a back and forward. And I don't think until we resolve some of the issues on the virtual world, we're still going to have to go back to reality. Because material, like right now, material behavior, like if, like the way that wood acts on the sun or steel acts on the sun is not programmed into any software. So you know that that beam on the heat is going to expand. It's a metal, so it will swell a little bit, or that concrete will contract on the winter. None of that intelligence is still built in any computer software right now. So we always gonna have to go back to the real world and test it and go back to the virtual. So that's where we are right now. Any other questions? Yes.
Say on that wall that said there's a question on light,
Yes.
would you have to go back into
Revit.
3D and then repackage it all and load it all again and then reopen it?
Yeah. It will be nice if it will be all seamless. So right now, it goes back to Revit. You do your changes, you package it, you send it to the cloud, and then it goes back to the VR ML software. So there are all these steps. Yeah. Yeah.
So is there a way to tell if it'll be too much sun while it's in Revit, or only when it's live?
You can start seeing some of this in Revit, but it's not as immersive. So yes, I will basically start testing it on Revit first. So when it looks good, then I take it into the VR, and then the VR is kind of like that final check. Yeah. When you have, let's say that this was an urban environment, you will have actually more views. So then that, as you immerse yourself, you're actually trying to understand the context beyond. So definitely at that point, you will go back to Revit and adjust things. Yeah. Yeah.
You know, in your computer applications class, is there any, do you integrate any GIS work in there? Like, well, you just said with like view sheds and context, it seems like there's a certain point where you want to bring in the world surrounding your design.
Like Google Earth.
Yeah, or ArcGIS or any of those sorts of things that bring in topography of other buildings.
Yes, there is those opportunities too, but sometimes it's not as, the rendition of it is not as good as I would want it to be. So I think it's developed for like major cities, but it's not, it doesn't have the same quality across. Yeah. So I teach a class where we do a lot of projects in Europe, and sometimes I have that difficulty of trying to find a lot of that GIS information, because I cannot put the students on a plane and take them to France or Italy, which I love to, but you know, it's trying to give them that immersive, what it is to be in a medieval town in Italy, you know, where everything is shrunk and very, the scale is really intimate. So how do I get them there? So Google Earth is the closest right now. Okay. Any other questions?
Well, thank you guys for your questions and discussions. If you want to learn more about the resources the Creative Studios and library have to offer, you can visit with the staff in the Creative Studios or check out the library website and search for Creative Studios. If you have ideas for future Tech Tuesday at 2 topics, you can tweet us with the hashtag using LibTech2s. Before we end, I also want to mention the Library Creativity Award. All OSU students have a chance to showcase their creativity and win awards in 2D, 3D, motion, wildcard, and best in show categories. You can visit our website or ask any of the event staff if you'd like to learn more. Now we're going to say goodbye to our live stream audience and draw for prizes. Thank you to OSTED TV for hosting the live stream, and thank you to all who have watched.